General Chemistry, Semester 2, Chapter 4, Metallic and Hydrogen Bonds, Module 4, presented by Dr. B. Madhavi, Assistant Professor in Chemistry, Department of Chemistry, St. Joseph's College for Women, Vishakhapatnam. Module 4 contents: intermolecular forces, van der Waals forces, dipole-dipole interaction, and London forces, and factors affecting van der Waals forces. Intermolecular forces. Intermolecular forces are the forces of attraction that exist between molecules in molecular substances. These forces helps to hold molecule together, especially in liquids and solids. One important type of intermolecular force is the London dispersion force. It is also called as temporary induced dipole-dipole interaction. These forces are present in all molecules, whether polar or it is a non-polar molecule. They arise due to unequal distribution of electrons around a molecule. At any moment, electron may be more concentrated on one side, creating an instantaneous dipole. This temporary dipole can induce a similar dipole in a neighboring molecule. As a result, opposite partial charges attract each other, leading to a weak forces of attraction between molecules. These are the weakest intermolecular forces. The strength of these forces depends on molecular size. Larger molecules have more electrons, leading to stronger dispersion forces. Therefore, large molecules have higher melting and boiling points. The partial charges in molecules are represented by delta positive and delta negative. Intermolecular forces exist due to unequal electron distribution within molecules. Let us understand this using a hydrogen molecule. In hydrogen molecule, two hydrogen atoms are joined by a covalent bond where electrons are shared between them. However, electrons are constantly moving with rapidity, and at any instant they may not be evenly disturbed. This means that sometimes more electrons may be present on one side of the molecule. Since electrons carry a negative charge, the side with more electrons becomes partially negative, while the other side becomes partially positive. This creates a temporary dipole in the molecules. These partial charges are not permanent because electrons keep moving. No atom actually gains or loses electrons. Instead, there is just a temporary uneven distribution. This temporary dipole can induce a dipole in nearby molecule, resulting in weak intermolecular attractions called as London dispersion forces. Temporary dipole and effect of molecular size. A temporary dipole is formed when electrons are unevenly distributed in a molecule at a given instant. The dipole is instantaneously and short-lived because electrons are always moving rapidly. However, in a substance containing millions of molecules, such temporary dipoles are continuously formed, leading to noticeable intermolecular attractions. The size of the molecules plays an important role. Larger molecules have more electrons, so there is a greater chance of uneven distribution resulting in shorter dipoles. If more electrons accumulate on the side, that side becomes partially negative while the other side becomes partially positive. Thus, larger molecules experience stronger intermolecular forces compared to smaller molecules. Permanent dipole-dipole interactions exist between polar molecules. In these molecules, a partially negative region of one molecule is attracted to partially positive region of another molecules. These interactions are permanent in nature, unlike temporary induced dipoles, and hence they are shorter than induced dipole forces. The strength of these interactions depends on the polarity. Greater the polarity of the bond of or molecule, stronger will be the dipole interactions. Thus, molecules with high dipole moment shows stronger intermolecular attraction and high boiling points. Intermolecular forces and dipole-dipole interactions. Intermolecular forces are the forces of attraction between molecules present in both polar and nonpolar molecules. These forces are also known as van der Waals forces or cohesive forces. They mainly arise from two types of interaction. The first one is dipole-dipole interaction and the second one is induced dipole interaction. The first one, dipole-dipole interactions occurs in polar molecules which possess permanent dipoles. In such molecules, one end is partially positive and the other end is partially negative. Due to this polarity, the positive end of one molecule attracts the negative end of another molecule, resulting in dipole-dipole attractions. Example including gases like ammonia, sulfur dioxide, hydrogen fluoride and hydrogen chloride. The strength of the dipole-dipole interactions depends on the dipole moment of the molecule. Greater the polarity, stronger is the intermolecular attraction. Van der Waals forces. J. van der Waals, a Dutch scientist in 1873, pointed that particles like atoms, molecules, ions of a substance exert attractive forces on each other when they are brought together closely to each other. These forces are electrostatic in nature and are much weaker than chemical forces. These forces are named as van der Waals forces. These may be defined as follows. Van der Waals forces are very short-lived electrostatic attractive forces which exist between all kinds of atoms, molecules and ions when they are brought together sufficiently close to each other. Van der Waals forces have no concern with the valence electrons of the species. They exist in neutral molecules, atoms and ions. Even in inert gas, atoms may develop these forces when brought sufficiently close to each other. London forces or London dispersive forces. London dispersion force are also called as induced dipole interactions. They are weakest type of intermolecular forces occurring between all atoms and molecules, even in nonpolar ones like oxygen and helium. These factors exist in nonpolar diatomic molecules like O2 and N2 and in nonpolar monoatomic noble gases like helium and neon. Some of the physical evidences. Their existence is proven by the fact that these gases can be condensed into liquids under high pressure and low temperature. Discovery was done in 1930 by a physicist called London. Electron oscillation. In any atom or nonpolar molecules, electrons are constantly moving around the nuclei. Instantaneous dipoles. At any specific moment, the electron density might shift to one side of the molecule. This creates a temporary instantaneous dipole where one side is slightly positive and other side is negative. Induction. This temporary dipole in one molecule repel or attracts the electron in a neighboring molecule, inducing a dipole in it as well as attraction. The temporary dipoles then attract each other, creating London dispersion force. Its strength, it is a weakest intermolecular force. The strength increases with the size of the electron cloud. Larger atoms or molecules generally have stronger London dispersion forces. These forces only act over very short distances. Liquefaction of gas. Liquefaction is a process of converting a gas into a liquid by cooling and or by applying pressure. Gas molecules are far apart. When we cool or compress, the gas molecules come closer and van der Waals forces start acting or pulling them together and gas becomes liquid. Example, carbon dioxide is liquefied easily under pressure, whereas helium is difficult to liquefy because of weak forces. Hardness of liquid. The hardness is the ability of solid to resist or deformation. It depends on how strongly the particles are held together. Strong bonding leads to hard solids. Weak intermolecular force leads to soft solids. Example, diamond is very hard due to strong covalent bond. Graphite is soft because the layers are held by weak forces. Joule-Thomson effect is the change in temperature that occurs when a gas expands without exchange of heat. When a gas expands, its molecular movement further apart. To increase the distance between molecules, the gas must use its own internal energy to overcome intermolecular attractive forces. Because internal kinetic energy is consumed to overcome these forces, the temperature usually decreases. Hence, cooling takes place. When gas is quickly released from a cylinder, the cylinder itself becomes cold to touch. This principle is the fundamental technology used in refrigerators and air conditioners to generate quick air or cool. Dipole-dipole interactions are the electrostatic attraction between the permanent partial positive end of one polar molecule and the permanent partial negative end of another. These forces occur between polar molecules and are generally stronger than dispersion forces but weaker than ion-dipole interactions. In the covalent bonding between two atoms of very different electronegativity, the bond becomes highly polar. This dipole can interact with other permanent dipoles. Two polar molecules floating in space each has a static positive and static negative charges. Ion dipole forces. They are permanent dipole interaction with an ion. This explains, for example, of solubility of NaCl in water. Ion dipole forces occurs when a permanent dipole such as water molecule interacts with an ion. This fundamental intermolecular force allows ionic compound like NaCl to dissolve so effectively in water. When we drop salt into water, the water molecule surrounds the individual ions. Because water is a polar molecule, it has two distinct ends. The oxygen atom carries partially negative charge. It is attracted to the surroundings of positive sodium ions. The hydrogen atom carries a partially positive charge. They are attracted by the surrounding negative chloride ions. Thank you.